into yet. So let me see if I can get a link. Right, got a link. Let me just copy it over onto Facebook. Onto Facebook. Going live. Post. Right. Hey Richard. Hey Matt. Oh, what a start. Right. So. I thought we would do some getting used to the keyboard and input on the Spectrum. Hang on, let me just shut myself up because I've got background audio. Here we go. Right. Close all the windows down so I can see what I'm doing. I think Slack's crashed on the computer. Oh no, it's gone. Right. Hey Ratmal, Stuart Guest and Adrian Sinclair, afternoon. Just so you know, today we're going to be doing some input stuff. So getting used to reading the keyboard. And we'll do some in BASIC and we'll do some in machine code as well today, hopefully, assuming we have enough time. Right, let me load up the next. Right, can you see that? Let me see if I can get. Yeah, you can hear me okay, can you? Petra Robbins, can you hear me okay? Hey Matt. Yep, okay, cool. Right. Actually, you should probably start with the art side of let's get OBS up so I can see what's going on. Right, if I put promotion up so you can see that. Right. Yeah, it's a bit manic today because I've been busy sorting things and a bit of firefighting and anyway, right. Keyboard. On the Specky, the keyboard is split into 8 lots of 5 keys. And just we have this top row. Hang on, that's not showing right on the screen. The cursor's way off. Anyway, the split up into 5 bits, 4 to 0. This is the address. We've got it in in binary and in hex. I haven't done the decimal yet. Like I say, the bits for each bit that comes in from that port are for the corresponding keys, like B, N, M, symbol shift and space, which is in the bottom right of the keyboard. Right, now I'll go backwards a bit because it's to explain where we are. We've got the words, right. These words for 16-bit for a 16-bit address or a 16-bit value, right? And the keyboard is but they're not very straightly lined up because I'm using a mouse. But the input port is FE, is the lower two bits. F and then E, and then let's just move that out of the way. And then, like I said, the lower byte is FE, which is 254 in decimal, and that is 11111110. And the bits for the keyboard are as follows, right? Basically, if you have them all 1, it means it's not going to read the keys. But whichever one you have as a 0, let's say we had that one as a 0, so if we take this off and have it as a 0, it will be 7 and F. And if you remember last week we had I haven't got on this screen, the bits are 1, 2, 4, 8, 16, 32, 64 and 128. Well, the bits for the nibbles is 1, 2, 4 and 8. So 1, 2 and 4 is 7, and 1, 2, 4 and 8 is 15, which in hex is F. Right, so this first one, if we go back onto my keyboard, this 7F here, as you can see on the other keys, let me just, I'm waffling on and I can't see what anyone's typing. The bit of background noise, that's possibly the noise of the fan on the laptop. Right, so as I was saying, these every bit of 0 going down, it just moves across a bit, and it's for each section, each of the 8 sections of the keyboard, and each section's got 5 keys. And so for 7F FE, you've got B, N, M, symbol shift and space. Right, and so for the next, if you move the bit across, it goes up a section on the keyboard. I haven't got a 48K here, but I have got my next. Right, let me see if I can. Was that in camera then as well? Right, yeah. Right, we've got. Let me just bring that screen back up so I can see what you can see. And in fact, what I'll do on the spectrum is make the screen bigger. Actually, you should probably start with. Let's see if I can find it. Right. I can't see what it's got there. Right, what I'll do is load up OBS again. Hold on. Sorry about this. Right. Video capture, and let me get this screen full screen so you can see me. Right. Sorry about this. I'll put the camera down a bit so you can see it. Right. We have the B, N, M, and on the 48 you have the symbol shift here and the spacebar there on the old rubber keys. Right, so they are the 5 bits B, N, M, and then it'll be simple shift and spacebar there on the old rubber keys. And spacebar. Right, so hang on, just shut me off. I've got me playing in the background, which you can probably hear feeding back again. That could be what the noise you were talking about. And spacebar. Just shut me off. I've got me playing in the background, which you can probably hear feeding back again. That could be what the noise you were talking about. Yep, there you go. Has that fixed the noise? Turn it around that way so it's not as busy. Right. How can we go that? I can't see what people are saying now. Okay. Hey Quang. Yeah. Sorry, the echo was me playing the video so I could see what was going on. Just unplug the controller buttons getting activated. Right. So we had the screen up again. Yeah. Right. We had the bottom row, which is 7FFE. Which is B and M, semicolon and space, which is on the 48K keyboard. So it'll be symbol shift and space when we test it later. And then the next row up, which is if I load up put the other screen back on. If I shut me down. Hold on. Can we just get promotion up again? Right. The next one is BFFE, which, as you can see, is the next bit down that we've cleared, and that will read H, J, K, L, and enter. Which obviously you can't see that me holding the keyboard, but you could have had it set up. Right. Then we've got the next one is YUIOP, and again then 67890. So if basically, let me put me back up again. So it basically goes around the keyboard, the 5 there, then the 5 there, then the 5 from U to P, then 6 to 0. Obviously we're not including the extended keys because it's the way the bits are read in. It's from the 48K. And some of these, like the 9 is shift and 0 put together, and same with the edit and break and stuff like that. They're all multiple keys. But they're still usually read as those 8 rows of 5 keys. So it starts off with the BNM symbol space, goes up, and then it goes over to these and goes that way. Well, bit 0, sorry, is space on the 7FA. So it goes backwards and then goes that way when it's reading it. So anyway, that's enough of that mind-boggling stuff. You'll probably want to try it out. Let's get me back off and let me get myself down. Long screen, I think. Yep. Let me scale myself down if it let me. There we go. Right. And now what we can do is go back into CSpec, and we've written a little program. 10 prints at 0,0 semicolon, K equals, obviously to show you that the key Hang on, I've not got the right screen on. Hold on. Oh, it's all going wrong. You just love it when this happens. Where's my mouse? Right. This is back. There we go. Right. So we've got 10 print at 0, semicolon, open quotes, k equals, close quotes, semicolon, percent in, open brackets, percent in. The percent tells the int that you're going to be given it an integer. So the integer is 7, hex 7FFE, which, as you remember, was the first bit, well, bit 7, or should I say bit 15 of the address for the port, being 0, which means the keys B, N, M, symbol shift and space. So this will print at the top left of the screen a K equals, and then it'll show me what value is coming in, and I put semicolon, quote, space, space, quote at the end just to clear off if it's printed a bigger number than 0 or bigger than 1 digit, it'll print 2 digits, and then when it goes back to a 1 digit, it'll still show the character. So I put the spaces on the end to clear any of the extra characters off, and then 20 go to 10. So if we run this, we get k equals 31, because with the keyboard the values that come in are inverted, so that when there's no key pressed it will be a 1, if there is a key pressed it will be a 0. So that 31 is, if you remember back to the hex stuff, let me just swap back over to promotion. Right, if you remember binary numbers, hang on, did I have the hex one in? Did I do a hex one? No. Oh, it was in that bits one, wasn't it? Right, okay. I'll save that and load the bits one. Right. So, the 4 bits to make the nibble, like I say, which is the lower 8 bits, but now we've got 16 because we've got over 16. We've actually got 31 because we only need these 5 bits here. So 31 is 16 plus 8, which is 24, plus 4, which is 28, plus 2, which is 30, and 1 is 31. And that's what we've got. So that means that all, let me put this 8 by 8 on the grid. Right. So all these are set to 1. And that gives us 3, 1. Right, so if we go back to CSpec, when I press the B key, we get 15. When I press the N key, we get 23. The M key gives us 27. The symbol shift gives us 29, and space gives us 30. And that will be the zeros. And then we can mix. So if I press B, N, and M, it gives us 3, which is 0, and bit 0 and bit 1 is a 1, which means the space and the symbol shift aren't pressed. So if I press space now, and if I press all 5 keys, it comes up as 0. Right, so hang on, let me just go back to thingy so I can see what people are saying. Right. Let me see what catch up on where you're up to so I don't miss anyone out. Yeah, the brackets are not needed, but I put them in anyway because it's old habits die hard. I'm used to putting brackets around port addresses with machine code in and out. Okay, make pool, no worries. You best not get you beat up. Good point, Matt. Right, so is everyone following with the bits for the keyboard on the next? Yeah, keys all work on their own. Right, now what we'll do is, if we go back to our bit screen of the keyboard, right, we'll just turn this back off a sec. Right. Yeah, so I should do M31 as well. Right, I will do that in the code in a sec. But right, with this with these numbers, like say we wanted to change it now, so it's HJKL and enter. It's BFFE. BFFE. So if we go into the CSpec and change the code to BFFE, BFFE, right, we get, when I press J, we get 23, K is 27, L is 29, no, sorry, H is 15, sorry, J is 23, K is 27, L is 29, and enter is 30. So if I press all of them, you get 0. Right, so again, we can change that for any of the addresses for the ports. So what I want to do now is get rid of that. 10, let x equals 0. 20, let y equals 0. 30, plot x comma y, or is it yx? I can never remember. I barely use basic, so it's probably yx knowing me, but I think it's xy. And then 40 if percent in brackets string. Right, should we do QAOP? So if we go to our keyboard, just let you see my keyboard, the bits for the keyboard. Right, we want Q for up. So that will be bit 4 of Q is bit 4 of FB FE. FB FE and 16 equals 0. Then let y equal y plus 1. Right, and 1000 go to 30. Run. There we go. No. Right. Let me just check to make sure. print in bracket string FBFE and 31. Sorry. Print at not semicolon. Right, so Q 30. Oh shit. I just pressed escape. Right, don't you love it when press escape and it quits the application? And just start up CSpect again. I didn't save it. Another reason for you to always save your program. Right. Here's CSpect. And I didn't even have it on for you. Right, 10, let X, let X equal 0, 20, let Y equal 0, 30, let X equal Y, right, 40, right, we'll do the usual way. In BASIC, using Inky string. If Inky string equals O, then let X equal X minus 1. 70 if Inky string equals P, and let X equal X plus 1, 1000 go to 30. Done it again. Pressing escape because I usually use escape to quit out. Sorry about this. And I will save before I. Another reason why you should save before doing anything. Yeah, it's good reason to save. Right. So let X wrong window equal 0. If you're typing away and then you wonder why your CSpect isn't working, it's probably because you've got another window active, like I just did then. Dot X comma Y 40 if Inky string equals Q, then let Y equal Y minus 1. Right. Do you know about variables? Anyone not know what a variable is? A variable is basically usually a label or a letter or a word or something that is given to a number that can change because it's a variable. That's because it changes, it means it's a variable. So they're called variables. So in BASIC we have like let X and let Y or plot XY. These letters are letters because they're in a variable, they're in an address in memory where they can be changed. So not a specific like plot 5,5, which will always be plot 5 at 5,5. So a variable is in, when using basic, is a letter usually that we have that will change. It means you can move it around, increase it, add values to it, divide it, multiply, no, do anything with it really. Let me finish this. If ink string equals a, then y equal what? Y minus 1, and it should be plus 1 on the Q. 60 if inky string, and again inky string is a Sinclair basic way of reading the keys. There is issues with it, I'll show you in a sec. Let x equal x minus 1, 70 if inky string equals p, then let x equal x plus 1, 80,000 go to 30. Right, save, plot test dot bas. Right, so we've got up, down, left and right, but as you can see, if I press Q and P, it doesn't move diagonally because it's only doing a check on a specific letter. You can't have it having multiple values when it's red. Right, so this is why we have to use the other method, which is what I'm attempting to teach now. Right, so instead of the inky string, we do if %in string 7FFE, not 7FFE, it was, where's our screen references so you can see what, have to fight with C-Spec to get the mouse back, sorry about that. Right, so promotion, we have right, we wanted Q, so it's FBFE and 16. FBFE and 16 equals 0. Right, let's see if that works. No, it doesn't. Right, so bear with me a sec, because like I say, I don't really use BASIC that much, so I use machine code more, so getting the ins and outs. Print at outcome. Semicolon quote. Percent in string FBFE. There we go. And 60. It could be a sort issue on the way it processes the command line. Let's see what this says. Hang on. Matthew Delayex, is that? Let me just read, see what I've missed out. Yeah, Blue 552. The reason I want to type along rather than have it prepared is because I can show errors happening, and I always find that when you show errors and then show them being fixed, it's also good. Because I know a few other tutorials that have been done with the basic, and then they've typed the program in, and then if they make a mistake, then they go over and fix it. I find it helpful for people learning as well, because if you're copying it and you miss something out and you type it in wrong, then what happens is you get an error and you don't know what it is. So if you can then find out what the error is and fix it, or at least have an idea on what it might be, then that's good. Well, I've forgotten to switch screens. Sorry, guys. Let me just open this. Right, you should have the screen now. Still not getting that up. Yeah, I need a stream. I need to sort out my streaming actually, because it's having to use OBS and then like swapping. I need more screens because I can't see it. Like if I swap over to OBS, then I can't chit in. I can't see what people are typing in, and then if I swap over to the live studio, then I can see what people are typing in, but I can't then swap the screens over and use and. Yeah. Thank you. It was the wrong and, wasn't it? It was the logic and rather than 16. There we go. I can get rid of line 100 now. That I didn't want to get rid of line 10, did I? Right. Ooh, that's not it either. Yeah, do need more. There's not enough screens in the world, I don't think. Ah, yeah. Totally forgot. Thank you. Q is indeed bit 1. Oh, bit 0. So I need to check for 1. There we go. Right. Now. So let me go back to this. Yeah, it's because I need to swap these around now. Hang on, let me just tidy this up so it's correct for people. That's my own fault. Sorry, I was rushing to get the to get it ready to get out and get it on live. Right. So, wrong one. It's that one. Q is bit 0. Let me do this quickly. And I've done it again, haven't I? Swapped the screen over. And so let me just get you back on CSpec promotion so you can see what I'm doing. Right, I'm just fixing swapping the bits around for the keys. Q, D, E, R, and T. And then we need A, S, D, F and G, must line up. Right, and then we have caps. And then Z, X, C, and V. God, that mouse is so responsive. Right, let's save that and breathe. Right, so Q is bit 1 of FBFE. So if we go back to our basic program, yes, that means swapping back over to CSpec. Right, so A should now be in string, and if we I'll swap over to show you what the thingy was. Again, swapping CSpec back. Right, so where are we? So we want A, which is FDFE, and again bit 0. Let's put CSpec back on. Into CSpec, and then so it was FDFE, FDFE, close and 1 equals naught. And Right, and then for O and P, and we swap back over to our keyboard layout. I'll put these screens on the video as well after. I'll put them in Facebook as well in the Spectrum X group. Turn that off. And O and P are all on the same keyboard, and it's DFFE. Right, DFFE and 1 this and 2 for equals 0. This is for O, and then if we have this one, brackets in string DFFE and 1 equals 0. Now if we save key test1.bas. Right, should be able to go diagonally. Yay! So now you can go diagonally anywhere you want. Right. Yep. As Matt said, it's basically just to show the basic principles. We're not getting into any like big coding yet. That'll be later on when we start making our game. But for the moment, for the next few videos, I'll just be teaching you like fundamental basic bits, so we can hopefully get people all on the same book and know what there is they're doing. Duncan Corpse, you're late. Yes, I was late too, so don't worry about it. Yeah, Matt Davis, you're right. 1 to 5 is backwards. One is bit 0 and 2 is, it's also backwards from the other ones. They basically come in from the edge of your keyboard. That's the way I used to remember it. Yeah, Quang, it was always the Inky string. That's why I'm teaching the how to read them with the import now, because it was so difficult then when using Inky string, because you couldn't do any diagonals, and or you couldn't do left and right and fire, which is something that you need for when you're writing games. If there's no point in just being able to move left and right and then having to stop every time you wanted to fire or jump. So yeah, it works on the Real Next. I'm only using CSpect because I've got a feed on a link to all the screens, so I can stream the screens. Otherwise I'd be using the Next to do it, to show you. Yeah, the upper bits on on port FE have meanings, because that's where the audio in and out are, well, for the speaker. Bits 5 and bit 6 are the audio and the mic, well, the speaker and mic. Let's try something. On out brackets 254. Actually, if you do it in, you have to do that, don't you? I think you have to do that. 254 comma 48. I'll set both bits, I think. Actually, no. It's not 48, it's 96, because I need to set bit 5 and bit 6. No, it is that. I should be able to do that. Yeah. 2 fact, if I do it on the same line, I don't know if it might be faster. 254, comma 0, comma, go to 1. No, you can't hear it. I was wondering if it'd do it fast enough, but obviously it's not going to get a fast enough frequency. You have to do machine code for that. Yeah, Matt, I know you can do it directly, but I didn't want to have it processing the floats to the numbers. I was using the int so it would be faster to calculate it to see if I could get any audio out of it. Right, anyway, so we have our thingy and you can go diagonally. We could even, I haven't got a sprite yet, so has everyone followed so far with, do you feel comfortable with being able to read the keyboard, any part of the keyboard, like reading the symbol shift or the space or the or any of the other keys rather than QAOP? Why would you read any other keys? Yeah, QAOP is enough, but you need fire or jump or whatever. So everyone read. Okay, let's do a quick test for you guys. Instead of doing QAOP, right? What would I change the Q to be? If I wanted this to be ZXPL, ZX left and right, and PL up and down. Yes, I know this is like, no, don't do nothing but QAOP, but we're just trying to see. I just want to make sure that everyone's understands the ports and the bits that is set to read the keyboard correctly. QSOP for you. QA seems awkward. Fair enough. QS, yeah, I suppose. Because then why not QSKP or QSPL? Anyway. Quick controls, yeah. They are lazy. Where they use the whole row of 5 keys, so they can just test any of the bits there. Right, so like I say, who can tell me what on line 40 the port would be for reading what is it? Y going up? So it needs to be a replacement for Q, which we'll go with P for now. So can anyone tell me what it is using the screen? If I put the screen up for you, actually I could probably share that screen in if I share that might help. Let's turn keyboard. Copy and then go to Facebook. And paste the pic. Right, so you now have hopefully that's posted now on the Facebook group. I don't know if I can post that. Does that link work? Right, well, P is not, the port for P is not FFFE. FFFE would be setting all of the bits, all of the upper 8 bits to to 1, which would read none of the rows of the keyboard. Basically, if you look at 7FFE, yeah, if I show you, right, this, can you see it? Let me just zoom the window so you can all see it properly. Right, if we go turn C-Spec off, right, make my window a bit bigger. Remove that one. Right, as I said, pretend for now these are symbol shift and space, because it's the 48K keyboard. Basically take off that and the bottom row. Right, so these 5 bottom keys are 7FFE, and then or the bit 15 in the address is clear. And if you move to bit 14, you get these. Bit 13, you get U to P. Bit 12 is 6 to 0. Bit 11 is 1 to 5. Bit 10 is Q to T. Bit 9 is A to G. And bit 8 is caps Z, C, Z, X, C and V. So basically if you start at bit 15, and then if you follow whichever row you want, just it's like say you wanted P, it'd be 1 1 0 1 1 1 1 1 for the address, for the top byte of the address. Yeah, alright, I'll pull the curtains, hold on. Right, yeah, it's a bit bright out there. Right, just getting back down there. Right, so where? Spec back up. Yeah, right, okay, let me get the binary and hex. Let me get C-Spec back up on this OBS. Right. Right, in the basically these are, if I save that out, if I copy that bit screen over to the thing as well, it could be handy for you guys. copy. Instead of doing one at a time. Right, I'll have to copy them one at a time then. Hold on. Copy. Right, and get the other one. Which one did I copy the next one? Right. So I've put the let me put a link to that on the chat. Right, does that work? Yeah, Z is bit 1, so that's AND with 2. X is bit 2, so that's AND with 4. Yeah. ZX. Well done. So yeah, DFFE was the one for P. So you're okay with these cheat sheets and pasted the wrong URL? Okay, hold on, let me just... see if that goes to the right link. Right. Well, you know the Spectrum Next group anyway. It's the post in there. Not sure how to get the a link. Yeah, by all means, pass the info on to Neil Streeter. Yeah. If anyone wants to pass the images on or use the images, feel free to do so. Let's get back to... And then you can even do let me just close everything, see spec back up. Right. Now, so 80, we can do if percent in string 7 FFE and 1 equals naught, then print at naught. Right, so we can move, and then space, we get the fire. Right, so we know that the fire is you can use, so we can basically have multiple of any key pressed and still read it from within BASIC. Right, now that you've all managed to get that, do we want to do a quick go on the sprites, or do we want to do that in machine code? What would you like to do? I'll let you guys decide what you want to do, as it's getting close to 4. I know we've only been going about an hour or so at the moment. But yes. What are you saying yes to, Adrian? You want to do this in machine code? Oh, sprites, okay. Right. Okay, people want to do what we've got so far in machine code. That's the reason why I wanted to do these, albeit very small programs, is so that I can show you what it is in BASIC and show you then the machine code conversion of it. And the reason for that is they will be kept small, and the smaller they are when you're doing a program and when you're teaching, the easier it is for people to take in and learn, because there's only small amount of code that you'll be changing. So that's why I prefer to sort of do the small snippets of code, because it's easier. We'll do sprites next week. Yep. Or homework. That's a good idea. What we can do is we can at the end of this, I can set a task for you guys, and that would be for next week. Not next week. The next 2 weeks is to, mind you, it's probably best for me to do a quick tutorial on how to use the sprite editor, and then we do we'll do that next. Actually, we'll do that next week. I'll do another one next week, rather than waiting 2 weeks. And what we'll do next week is I'll show you how to do that offline. I'll show you how to use the sprite editor, and then what we can do is at the end of that quick one next weekend, I will ask you guys to then make some sprites, because what we'll do is we'll use those sprites in a quick game. Well, not a quick thing that's sort of similar to this, but we'll have something moving around the screen and maybe firing or jumping. We don't know yet. We'll see how it goes. Need to understand palettes. Yeah, we can do palettes after the sprites. You don't necessarily need to understand palettes just yet, because we'll do that once we've done the sprites and got used to drawing things on the screen. Then we can show you how to change the palettes and stuff. Yes, a task would be great. Yeah, it would be, and it'd be interesting because like when a couple of years back when my daughters were in primary school, I had the kids year 5 and year 6, and they were making games with Game Maker. And basically, what I was doing is I'd laid out this plan of I would give them all the same things that they could do, like moving around with the keyboard control, and having collision and stuff. And what I said was, right, now I want you to draw your wall blocks, things that you can't walk through, and then a block for a character. There was no animation. We didn't do animation in it. It was just because there was only like 6 weekly lessons that we did for a term, and so I had to keep each like term small, so it was basically 6 hour lessons after school. And anyway, so we said we'll have the character that you move around your wall, and then we'll add things to it. And every single game that they made looked different and felt different. It was quite inspiring, considering that the tools that they'd been given were exactly the same. Nobody had any different information on what to do, but they all come up with different graphics, different games, different styles. It was really good. So yeah, what we'll do is we'll next weekend I will do a tutorial on how to use the sprite editor, and we'll use the sprite editor to make some sprites and characters for blocks, wall blocks and stuff, and have that moving around, and we'll get your characters moving around and up on the screen. And obviously what you'll have to do is post them in the Facebook group, and then we can I'll grab them and look at them, and we'll get them in for different game styles and stuff. Should be good, be interesting. Gaz Marshall, you can use Magenta Jim as a sprite. Are you going to make is that available for people to use? If so, I suppose we could. Yeah, hold on a second. No, I've got water. Sorry. That's it. I was looking for my water. Right. Yeah, .spr edit. Yeah, it was normally Retro Robins. Normally it will be every 2 weeks, but what I was going to do is because the sprite editor isn't really programming as such, it's just getting people used to how to use the sprite editor. So it's sort of not part of this tutorial, but it is part of the tutorial. So it's just like an extra one I'll kick in, so that it means that we've got some sprites for next week. As long as you guys do the sprites, then we should be good. Yeah, they can be anything. The sprites, like the kids did, it was all sorts. Like they had tanks and characters and balls that bounce around, and zombies and all kinds of different characters that come after you and stuff. It was great. So, like I say, we'll get the sprite editor tutorial done next week, and then get some sprites moving around. So let me get a link to this. Right, if everyone can grab that, that is a link to Odin, which is a Z80 assembler that is for use with the Next. Right. save that test as in test as in sorry, not bat, bass. So many file extensions. Right, now what you need to do, actually what I should do is show you how to, once you download that file, it'll be a .odin file. It's the link to Odin. Can you see that screen? Let me see if you can get a screen. Right, so this, on the link that I just sent in the group, in the chat, it's this link. If you click on this, it will download, and then show folder, right, cut, and next, tutorials, paste. Now it'll probably get renamed when you download it. Right, so if you just call it Odin with no file extension or anything, and then if you go into your I wish OBC would actually let me grab a screen, because it'd be so much easier if I could just use my second screen as the screen that you can see, but it's just allowing me to get thingies only, apps, add a display capture. Yeah, it's not adding. Nope, it's not showing up. So we can't do that. It's a bit of a pain. I'll see if I can get that ready for next week. But anyway, let's see if I can get Explorer showing. That's one window, right? That one, right? So actually, it's the GUI that I need to show, isn't it? Yeah. Right, with the GUI, we've got copy.odin. Hang on, let me go back to cspect and get rid of that. Close cspect off and go into the GUI, which is our cspect launcher, and the Odin file that we downloaded. If we scale it up so you can see the junk on the bottom, right, and then if you put that Odin into the dot folder and then just click that, that'll copy it across, and we should get Odin in here. Yeah, that's it, down the bottom. Right, and then we launch cspect, which should now bring up cspect. Yep. We'll just close off the other one. And right. So dot Odin, and then we should get that. Right. Is anyone following live or? yeah, Odin's in development. I must add that. So it's nowhere near finished. So this is going to be an interesting live show, and it is purely for my tutorials that Matt has even been kind enough to let this out in its current state. On a PC, it runs on the Next, Adrian, which is why I used the HDF GUI to get it in working with C-Spect using HDF Monkey, or use the GUI. And what it does is it puts it into an image file, which is the C-Spect Next 2 gig image file that C-Spect will use as your basically an SD card that you plug into your Next, which the image is basically a simulation of that for C-Spect to use. Download and install. Okay, let me know when you guys are ready, because there's no point in me continuing until you're all ready. The ones that are following on live. Can't seem to get HDF GUI to work. Did you install it last week? 2 weeks ago when I did the startup one. You're ready, Jeff? Good on you. I'll just try and get the others working, like Adrian. You put it in the dot folder, so you can call it up with the dot command and type in .odin. As long as you put it in the dot folder on the SD card or on the image. To see how are you getting on with it, Adrian? You got it working yet? Ratmel, glad you got it working. Richard, you got it working? No, okay. Yeah, what Matt's just said. If you set your let me put the HDF GUI window on. Right. If I close that down, actually. Right. The I got it open. Cool. Yep. Right. So, if you copy a file, so what you need to do is navigate to where you've put your the Odin file with this in Drive C, or I'll put it in Drive C anyway. Then tutorials, wherever you've downloaded it to, bits to add, Odin master, right, Odin. So you navigate there, and then in the other window, which is where you want to put it to, right, which is the root of your SD card or the image of your. This is the image file, or my image file anyway. And in the root folder, if there's a folder called dot. So if you go to the dot folder, double click on that, and you should have all the dot commands that you can use with the Next. And then what you do is you press that button there, which is the copy, and then it copies it across, as you can see here. copying Odin to .odin or slash dot Odin slash dot slash Odin. Right. Doesn't land. Yeah, no, I don't know why. I think it's just the screen. Whether it's to do with the scale or what, I don't know, but I really need to look at practicing with this Live Studio to see what, or an OBS to see why the mouse isn't coming up at the right position on the screen, whereas it should be, because yeah, it's the button for it is the 3 arrows to the right that take it into your SD image. The 3 arrows to the left are taking it back to your hard drive off the SD image. So the top one's copy to, but copy to SD or to the next, and the other one is copy from the next back to your hard drive. Yeah, have you selected your disk image? Disk image folder is blank. The right box shows nothing. Right, was it a 2 gig one that you did? Was it a 2 gig image? This C-Spec Next 2GB.image that you downloaded? Right. Z. It could be because it shouldn't be because you're on a Z drive. Should be all right. I would imagine so anyway. Yeah, choose the image. Yay. Right, cool. So you've got your, and then if you go to the dot command, the dot folder, you should get the same as this, demos, docs and dot and extras games on your image. Yeah, could be the something wrong with the 8 gig file, maybe. Okay, yeah, good plan. So have you got the? Is it pointing to your image file? In the box on the top left box next to the select image, is that pointing to your image file? Okay, we'll catch up. Okay, no worries, we shall carry on. So anyway, what you do is you point this to your dot command, click on Odin, and then click to copy it across, and hopefully it's copied across. Right, with the mouse being in the wrong place, but anyway, right, I'll close that back and get back to the Spectrum. Then we can launch C-Spec. Just get C-Spec back on. Yeah, there we go. And close off the other windows. and go dot Odin. Right, has everyone got Odin loaded up? Yeah, I was just going to say, the first thing we're going to do is show you the H key, which gives you help. Right, currently, just so you know, TL and TS, which saves and TL loads a text-based document, and TS saves a text-based document. Don't use them at the moment because there's an issue with that, which I found out before. And Matt is going to get that fixed. So we'll just be using L and S to load and save, but obviously we're not going to be loading anything at the moment. We're just going to be saving something before we run it. Right, so TS is okay. Right, okay. It's just the TL that's a bit buggy. Thanks, Matt. Hey Muzzy, hello. Right, so I to insert, and we want to start inserting at line 10. So we'll start off with our label start. Line 20, 4 spaces. I forgot what key it is for tab, so there's just 4 spaces for now. Then we want to do load, which is like let in BASIC, a comma 0, which basically does let a equal 0. And with Z80, you've only got 8-bit or 16-bit registers, whereas in the Speccy you've got a floating point, so you can go a lot numbers that are a lot bigger than 0 to 255 or 0 to 65536 for the 16-bit numbers. Right, and you've only got a certain amount of registers. A is the accumulator. Most of the things are done with A because it's the accumulator. It's the things that you can add and compare things to, and the rest are used as extra registers and 16-bit registers. So we'll start off with load A with 0, and then load bracket xpos comma A, and then load A comma A. We've already got A as 0, so load ypos comma A. And what that will be doing is that will store a byte in the address, well, in a register, well, a variable, which is a memory location in machine code. What xpos is and ypos. So we've set up the x and y that we had in BASIC. We had let x equal 0 and let y equal 0, and then we'll have a loop. Quick question, Matt: are we in interrupt enabled or disabled at this point in Odin? Because if I do a halt now for a pause for each frame, I want to be able to see it. But am I going to have to enable the interrupts, or am I okay to just do a halt? Interrupts are disabled. Am I okay enabling interrupts, or is that going to be an issue? Ah, okay. It should be alright running though, shouldn't it? It's going to be an issue. So I can't let, yeah, true. Yeah, I'll use a big loop. Okay. Cool. delay. Right, and then we do load DE, comma bracket export. Actually, no, we won't do that. We'll do, because that's one of the 16-bit registers. We'll do load A, comma bracket expos, and then do load E, comma A, and then load A, comma bracket ypos, and then load D, comma A. And basically, we're going to do the plot. So we'll do. I won't do a call plot because the call to a plot routine, because we on the next we've got functionality to do it. I'll do it as a call anyway, so you know what. Call plot. So we've got our X and Y in registers E and D. As you saw me do before, load D, comma bracket expos. That was to do to load up E with expos and Y with the ypos, because what I'm going to do is that instruction will get 2 bytes from memory, starting where the expos starts, and then it'll read that byte and the next byte and put them in E and D registers. The thing with the E, you've got 3, well, you've got more than 3, but you've got 3 main 16-bit registers: DE, BC, DE, and HL. And you can split them up, so you can have B and C. You can use them independently as 8-bit registers, or you can pair them off as a 16-bit register and they will be DE. So whatever values are in D and E are in the DE register. So you can change, like, do it load C, comma 8, and then that will make the C register, well, the lower byte in the BC register B8. Anyway, we'll do call plot, and then we want to do load we're not going to change the D register in the plot routine. So we want to do load BC, comma, and then string, because we want to get a port for the keyboard. Now, can anybody remember what the port was in the keyboard for Q? Who's going to be the first one to answer? Anyone got FB, FE? Very good, well done. Brownie point to Gaz Marshall for listening. FB, FE it is. And Stuart Guest, well done. FB, FE. So load B string, BC with BF, FE. Right, and then in A, comma bracket C, bit 0, comma A, because bit 0 is, if we go to our keyboard screen, let me just put promotion on. If we go to our keyboard screen, we have bit 0 is Q. In fact, yeah, I'll show you something else in a minute, which you might like. Just get C-Spec back up, and same for you guys, so you can see C-Spec. Right, so bit 0, comma A, JR, Z. Right, Z JR is jump relative, so it jump to a close a point in the program close to where we are. It's like 1 to 8 bytes either way, above or below where we are. Otherwise it'll have to be a jump. So if it's Z, which means the bit is 0, which means actually it should be NZ, because it's a 1 if it's not been pressed. So NZ, not Q. And then we can do on the in machine code, normally you start 0 as the top left of the screen, or should I say the top left of the screen, and then the bottom left is 191 0,191, 0 being the X and 191 being the bottom of the screen. But in BASIC it's sort of 16 pixels, 0, 0 is 16 pixels up from the bottom left. Don't ask why they did that, I don't know. It would have been better if they did it starting at the top left. But anyway, that's how it was, and that's how it is for BASIC and machine code. So not Q, so we want to decrease D, which is the Y position, as you can see in the you can't see a mouse, you can't even see the code actually, sorry. Let me get C-Spec back up. Right, let's see where you look up to. You're still following? Yeah, in A bracket C, sorry, although it really actually means in A brackets BC. It's the same with if you do in A brackets 254, that what gets put in the high byte is whatever the A register was before you did the in A brackets 254. So it always addresses a 16-bit address. It's just that you only give it in the bits that you type in. You only give it an 8-bit value. So it's C or the 0 to 255 for the port, the low byte of the port. Blue 552. Can you still see the programming screen? I did swap it back. Yeah, if we don't change it in Odin to do in brackets BC, A, because like Matt Langley said, if you do that, although it would be great and easier for people to use, if you try any other assembler, it won't work. So it's best to just keep it what the Z80 standard is of in A bracket C. So anyway, back up to this on the screen. So we've decreased D, which is the Y pos. We don't need. We won't do checks for. I suppose I should. Because I don't want it to go off the top of the screen, because it'll. Actually, I can do that inside the plot. So we'll just do dec D. So if it goes to 0 to 25, if it goes above 191, then it'll be off screen. But the plot, I'll make the plot not do that, not plot it. Right, so dec D, and then so not Q. Next we want to do load BC comma string, and then what's the next one for A? Does anybody know? Who's going to be the first one to say for the port for A? FDFA, correct. Gaz Marshall again. So You're on the ball. And Richard Faulkner, well done. Right. So in A comma bracket C, bit 0 comma A, because we're using A key, which is the first key on the left, the key closest to the edge of the board, so it's bit 0. Well, the edge of the keyboard, and then JRNZ comma dot comma not A, and then Inc D for A, because we want to go down the screen, and down the screen is increasing D, because the top left is 0 and moving down goes up. The Y goes up by 1, even though it's down. Down the screen. Right, and then not A, and then we do load BC comma for left. Any idea on what the key for left is? Who's going to be the first attack? It should already be on 3.5 megahertz, I think. Error line 120. DFFE. Yeah, DFFE is P, correct. Well done, Gaz. DFFE in A comma bracket C. Now what we can do is we can do a load L comma A. The reason I'm doing that is because I'm storing it, because we don't need to do the I'll just do an in again, doesn't matter. We'll keep it easy, we won't do any optimizations. Right, bit 1, because we're doing O for left, bit 1 of A, and then JRNZ comma not O, then deck E, not O, and then load BC comma string DFFE again, because it's on the same 5 key row, in A comma bracket C, bit 0 comma A this time, because we want to do P, JRNZ comma not P, and then Inc E not P. Right, loading runs at 28. These will be 8 times shorter. Right, okay. I will set the next reg 7 to 0 in a sec. Basically, now load A comma E, load bracket xpos comma A, load A comma D, load ypos comma A. Basically now what we're doing is we're storing the D and E registers back to put them back in xpos and ypos, and then jump loop, because that's what we call the main loop, and then we have our plot. Now we want to load A comma D and compare 192 and ret NC. So what that'll do is it will get the Y position and check if it's greater than or equal to 192, and if it is greater than or equal to, it will return, so it won't plot a pixel. Right, and now the bit that I've been waiting for to do for ages, normally with the Spectrum, because of the way the screen is laid out, it's a ball ache to calculate. If you want, I'll show you how to calculate it another time, but for now all we have to do is pixel add, and that will set HL to be the pixel address of DE. Whatever pixel DE is pointing to, E being the X position and D the Y position, HL will be, after running the pixel add instruction, HL will become the screen address of what you're going to write to. Now, because it's a byte and that's for 8 bits, or should I say 8 pixels, what we need to do is set the bit, and again, messing that around and shifting it depending on how many, depending on what bit is set. We added another instruction, set AE. Yes, I know it's cheating, Matt, but there's a good reason for that, is to make it easier for newcomers. So to do a plot, there's only basically 4 instructions. If you cancel the load A with, if you don't do the load A with D and compare 192 ret NC, the plot would just be 4 instructions, which will be pixel add, set AE, and then what that'll do is that will make the A register have the correct bit set for whichever pixel it should be, and then you just do or brackets HL, which sort of merges in whatever pixel is already on, whatever pixels are already on screen at that byte. It'll add or it into with the new pixel that you've just written or you're about to write, and then load bracket HL comma A will put that address, put that value back into the screen address. So that's the 4 instructions that will plot a pixel. Pixel add, set AE, or bracket HL, and load HL with A. And obviously return because we're having it as a function. And then we'll have a delay. We can use HL because we don't have a del loop. Dec HL. Load A comma H or L J R N Z comma del loop ret. Right, now the thing is, Odin runs at 28 megahertz, so it can be quick. So what we need to do is at line 15, we need to do next reg 7,0 to slow it back down to 3.5 megahertz. Just so that delay is actually some kind of delay. Actually, what I might do is 61 call delay 62 call delay 63 call delay, because unlike basic, machine code is bloody quick compared to basic. Yeah, I know it's cheating, and it's a good cheat. The reason for it was lots of people have asked how you get stuff on the screen, and I thought if you can make it easy for people to get to put stuff on the screen, the ULA screen, specifically with that instruction, it's because it's so hard for newcomers to work out how to calculate the screen address. There's lots of messing around with the bits. It was just a lot easier to do them 4 instructions. So that's why we have the pixel add in. Right, so now if you've followed with the instructions so far, who's cheating by using ROM? Darryl Sloan, wait. What do you mean mine's gone off screen? Oh, have you missed something out? Yeah, there's the start. Yeah, I don't want to renumber just yet because I want to assemble it and run. Right, can you see that screen okay? You ready for me to go to the next screen, or are people still? Oh, you'll need to go back and do Odin, okay. Adrian, so you've got Odin in and working. Have you got Odin working? Yeah. John, cheers. Line, what is it, 120? There's a bug for you, Matt. Another bug for you, Matt. When you press shift on you can't stop it unless you press them both at the same time. If you press shift, it'll scroll up. So there's another bug for you there to fix, Matt. Right, so 120 is for Q, which is FBFE. FBFE. Thank you. Right, so yeah, ignore shift by itself basically, Matt, and might as well add symbol shift to that just in case. So if we do save plot test asm, are you ready for the big shock? Will it work? No. Yeah, there we go. We need our variables 580 xpos db0, 590 ypos, I forgot to put them in, db0, and they need to be at the end because you can't put them in at the beginning because it starts running the code from the beginning. So what you do is you usually put the variables like at the end or after your main loop or something. So we'll put them at the end of the code. So we can now save that again because we want to make sure. So plot test asm. Cheers, Mike. I nearly did. Well, I did forget my X and Y pos. Yeah, there's no org yet or anything. That's why we're not. There's the reason we're using it at the moment is because it works for the small bits that we want to do, and because it's still very early days with the assembler. Matt's still got a bit to do, like with the org and ink bin and include. It's all got to be in the one file at the moment and stuff like that. So, which is handy for us because we're only doing small things at the moment, so it's not an issue. So by the time we get to doing bigger things, I pretty much guess that Matt will have it sorted with the ink bin and include and org and everything. So don't worry about it; it'll all be okay. Right, so assembled okay. Has everyone else assembled okay? Yeah, no pressure, Matt. Has everyone else assembled okay? And I believe in you, Matt. You can do it. You got us this far with it. Not sure how to end. Adrian, press. Sorry, if you do H, it'll show you a list of the commands, and then if you press I, it'll allow you to start, and then enter. It'll start with line 10, and you'll be able to type in the program. If you want to, I'll just put the first line of code on. You'll be able to see that, and then what I'll do is I'll wait a little while for you to type it in. Obviously I can't wait too long because a lot of people are here with us. You think delay is too long? I think so too, but we'll say it is machine code. If not, I can always sort it. Oh, I want it to be a slow so you can see it moving. Yeah. Sorry, I was. Have you? How far have you got, Adrian? Scroll back and catch up. Yeah. Okay. Well, let us know when you're when you've caught up. Has everyone else got it assembled yet? Rich, Gaz, yeah. Let's give it a try then. X. Oh. No, we've not got anything on. Okay. Right. Time to close CSpect and start again and load it in, see what happened. Ah, it could be the delay being too long, very true. Right, let's get CSpect back up. Change the delay. I'll just have one delay actually. Dot Odin and load plot test asm. Right. 61, 62, 63. And is it worth me typing D61 to 63, Matt, or should I just leave it as it is for now? Yeah. Oh, that's a good idea. Add an RST instruction for a frame weight for next time. Good plan. So if I D61 to 63, that should get rid of, yeah, line 61 to 63. Whew. And I might, in fact, just make it a smaller delay. Make it 30,000, so it counts to 30,000 before it moves. Right, assemble and save. Plot test asm, and then we have it moving. Hey, I don't know why it started in the middle. Right. And we have to restart it because each time, because we haven't got any exit functionality in there yet. I suppose I could add one to it. Load plot test asm. I suppose 3, 9. Hang on. Let's see where we're going on with this. Equals D plot. Pixelad set a channel date driver. Yeah, and it fails after TL. Matt, that's correct. That's why we're using S to save and L to load, because at the moment there's an issue with TL, doesn't quite load properly. Change that to 3000. Save. Plot test asm. and down isn't working. Right, so let's start that again. Each time I'm quitting out with escape, just so you know, because we've not got it returning back to Odin yet. So you have to quit out and start again. Load up CSpec and start it again. But load plot test as yeah, I should be able to rep back, shouldn't I? So what I'll do now is 391 load BC comma string 7FFE and 392 in A comma bracket C 393 bit 0 comma A 394 ret Z. And if I rename that and save plot test as them, assemble and run, you should be able to move and space to come back. Just with that little bit of code here, from 410 to 440, which basically gets the port 7FFE, which is this BNM symbol shift and space row of keys in A comma bracket C. Basically gets a byte from the port and puts it in the A register, then checks bit 0 of A. Bit 0 is the space key, and returns if 0 when it's 0 coming in from the keyboard port. It's set if the key has been pressed. So that is what that little routine does, and the that will return from the function that called this. And because there's nothing, we haven't got a bit that called start or called loop, then that's why it returned back to Odin, because Odin was the routine that called start. Right, now I need to find out why D is not getting changed. F FB and FE. Right, let's check these addresses. FB and FD. FB and FD for Q&A. FB and FD. What is that? Q and A. That is bizarre. I do not know why. A, it's starting off in the centre of the screen, and B, why it's not going up and down. That is very strange. Let's see. Right. Speed to 0. X and Y to 0. Call delay, which only changes HLD. Have the scroll registers been changed at all with Odin? Hang on, I know what we'll do. Right, we will put line 55 and load a comma string 55 56 load right string 4000 comma 8, and that will put 4 dots, or 4 alternate dots in the byte at 4000, which is the top left. AX, yeah, there. Strange. Could that be something to do? Could that be a bug in? Could that be a bug in Thingy Mat? Any idea? I see what I mean, yeah. Okay, we'll do that on the first thingies. So line, if we put a ret after the, where is it? Line 111, 111, ret. Make sure it's in the right place before the plot. Right. So that should be DE being, yeah, 59. Why is DE 59? Possibly. I have an idea. Are you ready? Let's change the DB to NOP, and that should be the same thing. Right, so no, it's still 59 in DE. Hang on. Delay doesn't change DE at all. Yeah. Right, let's go into the disassembler. Right, are you in there with me? Yep, right. PC, actually string D1:0. Right, so next reg 7:0. 3 is load A with 0. Load 806B, which is XPOS, with A, and 6C, which is the next byte, which is Y, YPOS. Then load A with 55 hex, and load the contents of the screen 4000 with A. CD is call 8062, which is a plot. 8062 is a plot, which is 20, yeah, that's that's 21. That's on anyway. Another great reason for the manual. Might as well use it as we have it. 21 hex. Is load HL, comma NN, which is load HL with, I should have known, 21. I usually have it as a decimal, 33. Load HL with 3000. Is that calling me? That's calling delay, isn't it? Yeah. So that's the delay bit, and then it's get X and Y pos, and then call it. So, right, we have the call, delay, and then load A with 3A. That's wrong. So that load A with content 3A. 3A. Is it 3A? Yeah, load A with the contents of, so it's right, 3A, 5F. That's loading from the wrong address. So XPOS and YPOS are changing. I seem to have a bug for you, Matt. Yeah, it's always good to follow debugging, which is one of the reasons why I wanted to do it live as well, because basically when you see things not working, it's I know it's load A with brackets NN, which is what it should be, is load A with E, load brackets XPOS comma A, and then load A with D. Load A with XPOS. It is load A with XPOS, and then load E with A, and load A with YPOS. Load D with. Let's see if I can get it on the CSpec screen. Yeah, it's line 80. Load A with XPOS, load E with A, and load A with YPOS, and load D with A. And return. But they should be 0 because they've only just been set to 0 by the code. But XPOS and YPOS are being read differently. In the first instruction, the load XPOS comma A, that's coming in. If we go into the debugger, we've got the instruction, where is it? This is the first one, load A with 0, 3800, and then 6B32 is the address. No, sorry, 3 is load A with 0, and then 32 is load the contents of that with A. So it's 8036B, and then there we go, 806B there. Well, it was 8062. It's called 8062, which is the plot, I think. Right, let's go through this properly. I've got the ED91 is next reg 7,0. Load A with 0. Load contents of 806B, which is where thingy should be. XPOS, and 6806C is the YPOS. Then what's the next instruction? 55. Yep. So 3855, and then 32 would store it in 4000 hex, which is the screen. Call delay, and then after the call delay, what have we got? Load A with load A. Call delay, and then load A with 3A 5F. That 3A is not load A. Hang on, what? Load A brackets 3A. Yeah, it's load A with brackets and then, isn't it? 3A. Load A brackets and then, yeah. So it's 3A 5F. So this address is wrong. So that's an issue for Matt to fix for the next time. Yeah, good plan. See for 806B and 806C, which we got that before, but it's the instruction that is going wrong is the line 80 load A with XPOS, because that load A with XPOS should be this 3A. Could it be it's and then ret? It's only doing a 3A and then just saving 1 byte. That could be the issue there for you, Matt. It's just using 2 bytes instead of 3 for load A, brackets NN. Can you see that what I'm pointing at? Oh no, you can't see what I'm pointing at, can you? Because hold on, let me get OBS. I didn't realise the disassembly is off. Right, it's because it's full screen. I changed the resolution of the window. Let me see if we can get that back. C-spec. Right, so the ED7, now that you can see this, Matt, right, we've got the ED9170 is the next reg 7,0, which puts it back into 3.5 megahertz. Then we've got the 3A00, which is our load A with 0. Then we have the 36806B, which is what the address is correct for load brackets XPOS, A. And then we have the 326C80, which is load brackets YPOS, A. And we have load A with 55, 32 load brackets 4000, A. And then we have the call to delay, which is 8062, which is correct. Then we have 3A5F and 3A57. These are the 2 bugged instructions, which we have load A with XPOS and then load E with A, and then load A with Y pos, load D with A. So they are messing up. 5F is 5F load E with A. Very possibly, I think it is. 5F load E with A, yeah. Right, so Matt, what is happening is your 3A instruction isn't writing or isn't adding 2 points to the 2 bytes for the address, so it's just doing load. That's probably why some of the other things haven't worked as well. Oh, I'm still on screen. Right, so did you follow that? Yeah, it's writing the address wrong. Excellent, glad you got it. Just sorted. Right, what I suggest we do then is, I mean, as it's 5 o'clock now anyway, if we give that a rest for now, and then what we'll do is me and Matt will get busy getting this fixed, and me and Matt will be getting busy getting it fixed. I will help him as much as I can so he can get all the bits that we need working for the tutorial. And what we'll do is we'll do another one next weekend. We'll finish this code working next weekend, hopefully, if assuming Matt can get it fixed by then, which I think he should be able to, because it's pretty much straightforward. We know where the bug is now. He knows what it is, so it should be an easy fix. And what we'll do is next Sunday at 2 o'clock, we'll finish this off, get it running, and then we'll do the sprites next Sunday. We'll get this running, and so you can move around like you did with the basic version, and then we'll do the sprites on Sunday as well. And then we'll give you the homework for you guys to do some of your own sprite characters and stuff and blocks for the background, and then we'll get that in 2 weeks. We get that up and running from what you've done with your homework. I know, yeah. It is always the ones I use, sorry. But at least we're finding them now rather than later, and you've released it. And if we can get it working with the instructions anyway and making sure it's all good to go, then it means that when people take it and practice with it, then we can relax knowing that what they do with it will work. And always fun doing stuff live. Especially when it doesn't go as planned. You're thinking, why is that not working? It should be working. It should be at the top left. But it was a bug in the assembler, so easily done. The assembler isn't ready for human consumption anyway at the moment. It was only me pestering Matt saying, please can I use it, because I want people to follow on with the tutorials, as it would be great fun. What I will also do is I will save the source for this bit of the program, and then we can carry on with it next Sunday. Right, where are we? Yeah, there's lots of stuff being worked on, and lots of stuff is still early days with tools and stuff. We have a lot of them finished. Even the sprite editor, that still needs stuff doing to it. I want to do a 4-bit version as well, because obviously you can use 4-bit sprites on the next as well. but for now I'll just be doing 256 colour sprites. Yeah, does that work? Okay, let's see if we can do that, Matt. Right. Right, so 80 dB string 3A, 85 DW XPOS, and then 100 dB string 3A, 105 DW YPOS. Right, now let me see if just making sure I'm not getting it load. Right, that should. Oh, hang on. We forgot to take our ret out. Where is it? 111. D111. Right. So if we save, plot test as them. There we go. And then assemble and run it. Yay! Hey, we have it working. Yeah, we're not including macros, not yet. Not in these tutorials anyway. Not for now. Maybe once the assembler is complete and has macros. I don't know if it does yet or not. Maybe it does. I don't know. I haven't pestered him that much yet. But as you can see, it's working. And if you go off the top, wait a little while, and then it comes on the bottom. And same if you go off the top, off the bottom. Yeah, there's no rush for macros yet, Matt. They're not overly necessary. But there you have it. We have a pixel drawing thing in BASIC and in machine code, and you can do diagonals. So and there was a bit of debugging and tracing and tracking and using the manual. Nice one, Phoebus. Much appreciated. I used to do the hex codes off the manual. The pages in the manual, if you want to know, they start at page 315, and then they have the hex numbers. Let me see if I can zoom my screen. Zoom me up so it's nice and close. Need to get my mouse off C-Spec. It keeps pinching my mouse. Right. So, okay, let's just right. In the manual, the Awesome Spectrum Next manual, I even used the original manual for this back in the day when I was first starting. We have the next, the hex values, and the Z80N assembler, or the mnemonics, and these are the after BC modification, after ED. We'll get into them late at a later point. And again, so basically from page 315 to page 320 are all the hex and the decimal also values for each instruction on the next. Right, let me shrink me back down again. And hopefully, let's see where you're up to. back in the day, debugging was a lot harder because you couldn't just press F1 like on C-Spec and bring up all the memory and addresses and all the registers. Basically, you had to print stuff on the screen or turn the border a different colour, which we'll probably do something like that later on when we do some more demos later. We used to use changing the border colour for timing when we wanted to get stuff timed right for doing like border effects or which we can go into as well. We can go into them for later on, doing some border effects or attribute effects for multicolour. I mean, I know you can use layer 2 or whatever now and stuff for to replace the attributes, so you can have a different colour per pixel, let alone per attribute, 8 by 8 pixels. So, but yeah, we'll do some colour tricks for the original Specky and show you how we how I did them back in the day when I did Guts, like the colour in the borders and the colour on the menus and stuff. Yeah, you missed a couple of opcodes, Matt. Just a little port one, just a smidge. Want to use like a little bit. So, was this okay for you guys? Was it clear enough? I know it was a bit jumbled and started late and everything, but at least you know now how input works, how the bits, which is why I taught the numbers and bits in the first one, because you need to know them basically for Guts. I enjoyed that. It was a good game. But yeah, the reason for doing the numbers at the beginning and teaching you the bits is because so you know how they work on the screen and how they correlate to reading the keyboard, which is also important in even in BASIC. If you wanted to learn how to get your games being able to jump diagonally or fire while you're moving, you can read the keys as you want with being able to read multiple keys at once. Hoping these are clear enough and coming across okay. Yes, I will admit none of them are pre-prepared, because the only thing I do is normally set up the screens that I've shown you, like the bit screens and the address screens. The reason being is I find with doing it live anyway, I want you guys to have the interaction with you guys, and so things change. So like we were having to do the so if I'd have pre-done this and had it working, I would have to make sure that it was working, and we wouldn't have been able to go live anyway, because Matt needs to fix the bug. But yeah, I'm glad it's all working okay, in the fact that you guys are following along with the numbers and how the bits work with reading the keyboard. So yeah, good, and I hope it helps in any way, shape or form for you to eventually be able to make your own games, be it in machine code or basic or both, or yeah, a mix of both, because you can. In fact, I will show you doing some things in basic and machine code. So what we can do is we can write a bit of machine code and then save it out, and then what we can do is use a bit of basic and incorporate the machine code. So for those who still want to make a game or feel more comfortable making a game in basic, you'll be able to do it in BASIC, but do stuff in machine code that you can like perhaps use for drawing tile maps to the ULA, because I don't think Next Basic does that yet or at all. So what we can do is I'll teach you how to maybe after the sprites we'll go in for drawing a character map on the ULA, and then we'll work on doing like a character map, an 8x8 character map on the layer 2 screen, and maybe do some tile map stuff, but that'll be obviously as we progress through these tutorials. Adrian, well done. You're getting there then. Hopefully it's clear enough to follow. But yeah, we got it working. Yeah, no worries. Finish later when you can, Adrian. Like I say, the point of doing it on YouTube is the fact that it's recorded, and you'll be able to follow it anytime you want, and it's I'm not doing it on a paid view, a paid only view, so it's not just for the Kickstarter backers. Yes, it was a stretch goal for me to do these, but I want these to be for anyone who wants to learn how to program in BASIC or machine code. Yeah, it's gone down. Matt, it's recorded. It didn't work, but it was recorded. Yeah, John, that is my point exactly, John. The thing about how other people program and code, a lot of software companies have what they call coding standards, and in idea wise that's a good idea, but the problem with coding standards is every single company has different coding standards. Some like tabs, some don't like tabs. It's just there's so many different rules that as long as it gets done and it's done okay without bugs or anything, that should be good enough. He says bugs, and we just had Matt have his bug. No offence, Matt, but I know this is early days. But what I'm saying is other people people program in different ways, especially like a lot of the older programmers anyway, because if you're self-taught, you've not been taught by someone in a university or something who probably even then has never been in the games industry, so they don't know how the games are programmed. It's just everyone programs their own way. It's easier if you teach yourself. If you experiment, you can still teach yourself by using these tutorials, but how you interpret it and then use that going forward to make your own stuff then becomes like your way of programming. And it's like with the kids when I had them doing making games, all the games that they made were totally different, but they all had the same guidelines, same instructions. So like I say, it's every person's like vision of things is different, so you can't really say this is exactly how you do it and what you're doing is wrong. I wouldn't say that to anybody. Whatever way you're doing, for me, if it works fast and optimal, it doesn't even have to be optimal, depending on as long as it's not like running stupidly, like 1 frame a second or whatever, then it's fine. Yeah, John, coding standards or whatever you want, and that is, it's basically the coding standards for every company is the most comfortable way to program for the lead, the top programmer in the that company, because whoever states what the coding standard is, it's just how they prefer to program. It's not they're not actual standards. It's just their standard way of doing it. Well, that's my view of it anyway, from what I've come across. Matt, it's not a mistake. Don't worry. It didn't work. But the thing is, it was never ready to go out yet. It was Odin was never planned to be finished this early. It was just me pestering, saying I'd love to do it, like with people following on, and can I use it? And you said yeah. And so the fact that it's not all there yet, don't beat yourself about the bush with it. But we'll get there and we'll get it sorted. Whether it's next week or week after or whatever, as soon as it's done, we can move on. Yeah, well that's it. If we didn't check it now, you wouldn't have found the bug. It may have been harder to find at a later date when the code that people were making was a lot bigger. At the moment, we're just making little small routines, which is great because we're getting to use different instructions and basically doing a proper like runtime test on separate instructions. Well, people will trust the assembler because basically we're going to get it working with all the instructions anyway. So yeah, there's always bugs. There's always something that isn't quite right. Well, there's always something you want to change or fix or modify to make. Oh, that would be easy. Like the in a bracket BC. Some people want that, but it's like, well, do we make it so it does both? Or the thing is then, but if you're changing that, then it's going to mess things up when you come to using a different assembler, and everyone will then have to be stuck with Odin. So it's probably best that we don't change the instructions for the next inside Odin. Have you found another problem, Chris? Automated testing. Yeah. But then the problem with that PED is you have to write the automated test program. We are the unit test, don't worry, Matt. Yeah. Mind you, I suppose you've got the Lua scripts in. Is it Lua scripts in CSpec that you can run, or is it or is it Java, or is it Lua? I can't remember. Anyway, there is some scripts you can run in CSpec. Exactly, John. The big automated test has given it to someone else, and that's basically what he's done. Well, he didn't give it to me. I sort of pestered him into letting me have it because I wanted to make it so everyone could do it. Everyone who has a Nextdoor, who's getting a Nextdoor, who wants to join in with CSpec, or even ZX or Caesarus, or however you pronounce it. Anyone who wants to use that can do and join in. yeah, it's yeah, Richard, you hit the nail on the head. No, Odin does look great, and it is still really early in work in progress. And for Matt to even let that out is, for me, is a huge honour for me, because not many people let things out that they're still working on and they've not had time to test yet, especially to somewhere where they're especially going to be testing it live, and allowing other people to use it and test it live. No worries, Matt. No, I'm really appreciated that. Really appreciative of you letting me use this. Yeah, the one-off code that failed. We found it live. But yeah, happy to do so. No, it's great that you actually let me use it. So I will happily test it for you as much as you want. Right, anyway, it's 5:30. This has been going on for however long, since 2:30, whatever was it. So it's been going on 3 hours, so might call it a day. And I'll see you next Sunday at 2. Thanks for joining, and thank you for saying it's a great show. We got there in the end. A bit of a late start, but yeah, seeing the Recritch. And Matt and anyone else who wants to join in and Game Arise, no problem. And same for you, Ped, thanks. And Damien, you're welcome. And Chris. Bugger off, mate. See you all next week, and yeah, have a think about what you're going to do, what you guys want to do for your sprites. We will be adding all the sprites into the background as well. So we'll have a couple of sprites for background and a couple of sprites for characters, like one character for you. We won't have any animation, because we're just going to go through them simple. We're not going to go too deep into it, because I like to keep them small, because otherwise, go on for hours. Yeah, catch you later. See you, Krang. Hope the Stuart guests, thank you very much. I'm glad it was very informative, and I hope the rest of them will be. And see you next week. Bye all. You shut this off.